In April 2019, a telescope in Australia recorded a single thin beam of radio energy coming from the direction of the closest star to our sun. It sat at one precise frequency. Nothing natural is supposed to do that, and then it was gone. We have never heard it again. The star is called Proxima Centauri. It is the nearest stellar neighbor we have, just over 4 light-years away. By cosmic standards, that is next door. It is a red dwarf, small and dim, glowing a deep ember red, far cooler than our sun. For most of human history, we never knew it was there, because it is too faint to see with the naked eye. But it is close, and it has planets. At least one of those worlds, Proxima b, orbits inside the zone where liquid water could, in theory, exist. A rocky world, roughly the size of Earth, circling a quiet red ember in the dark. That is the place the signal seemed to come from. The telescope was the park's radio dish, a giant white bowl tilted toward the southern sky. It was listening as part of a project that scans the heavens for anything artificial, anything that does not fit the patterns of nature. For 30 hours it stared at Proxima Centauri, and buried in all that data, an analyst found something strange, a narrow spike, a signal compressed into a sliver of the radio spectrum, just 982 megahertz wide at the bottom of the band. Here is why that matters. Nature is messy. Stars, gas clouds, exploding worlds. They all broadcast across wide ranges of frequencies. They smear their energy out. But a signal pinched into one impossibly thin line is different. As far as we know, only one thing in the universe produces narrowband radio signals like that. Technology. Our own machines do it. Radio stations, satellites, spacecraft. So when something narrow arrives from the direction of an Earth-sized planet around the nearest star, you stop breathing for a moment. The researchers gave it a name. BLC-1. Breakthrough Listen. Candidate 1. The word candidate is doing a lot of work there, because for the first time in the history of the search, here was a signal that passed the first tests. It came from the right place. It had the right shape. And it did something that made the hairs on the back of the neck stand up. It drifted. As the Earth turned and moved through space, the frequency of the signal slid, slowly, smoothly, exactly the way a transmission from a distant moving object should. A signal coming from a faraway world should shift as both planets glide through space. BLC-1 shifted. It behaved like it was real. It behaved like it was out there. For months, a small group of scientists held this secret and tested it from every angle. They asked the obvious, deflating question first. Could this be us? Could it be a phone, a microwave, a satellite, some piece of human electronics leaking into the dish? Because Earth is loud, we are drowning in our own radio noise. Almost every promising signal ever caught has turned out to be a malfunctioning oven or a passing aircraft. They went back through the data, and what they found was unsettling in the other direction. Whenever the telescope pointed away from Proxima Centauri, the signal disappeared. When it pointed back, sometimes it returned. That is exactly the behavior you would expect from something in the sky, not something in the room. It clung to the star like a shadow, so they kept looking. They searched for the signal again and again. They pointed the dish back at Proxima Centauri, hoping to catch it a second time, to confirm it, to prove it was no accident. And the sky stayed silent. BLC-1 never came back. Whatever it was, it appeared once, drifted across the data for several hours, and then vanished into the dark for good. That silence is the heart of the mystery, because a one-time signal is almost impossible to confirm and almost impossible to fully dismiss. The scientists did the careful, honest thing. They dug deeper, and over time they found that BLC-1 was probably not a transmission from another world. It seemed to be tangled up with the messy fingerprints of human technology, faint harmonics, echoes of frequencies we ourselves produce. The most likely explanation, they concluded, was interference. Something on Earth, something ordinary, wearing an extraordinary disguise. But notice the words they used. Probably, most likely, not certain, because they could never find the exact source. They never pointed at the microwave or the faulty circuit and said, there it is. That is what fooled us. The match was close enough to suspect, but never close enough to prove. And so BLC-1 sits in a strange limbo, almost certainly a ghost made by our own machines. Almost. There is something deeply human in this story. We built instruments sensitive enough to hear a whisper from the nearest star. And the first thing they brought back was a riddle we could not fully solve. A signal that arrived perfectly, behaved perfectly, then refused to ever speak again. Proxima Centauri is still out there tonight, a dim red coal in the southern sky, with a rocky world turning slowly in its glow. We have looked at it for thousands of hours. We have heard nothing else. Maybe BLC-1 really was just an echo of ourselves, our noise reflected back, dressed up as a message from the stars. Or maybe, for a few hours one autumn, we caught something real, something that touched our antennas once and then went quiet, and we will spend the rest of our lives unable to prove it ever happened. The frequency it lived at is empty now. We are still listening. So here is the question that lingers in the dark. If a signal arrives only once, from exactly the right place, and never returns, how could we ever truly know what it was? And how many of those whispers have already passed us by, unheard while we were looking somewhere else?